today because for tomorrow I reserve problem 4 and 5. This question came in midterm too, right? Something like this is coming again. Something like this is coming again. Where you're going to have it in terms of theta like that. They're going to ask you to find what is it of x, what is it of x squared, what is the variance of x. That's going to occupy, let me see. Did I put part 2? I can show part 2. Yeah, that should occupy part 1. So how do I go about a problem? They've told you here. Whenever you have a distribution given in this way, that should tell you that's going to be a discrete. That's why we have a PMF, right? PMF means probability mass function. Okay, so if I want to solve for, the E of S, and let me tell you this. You're going to see here, you can see a subscript theta because of probability. They are in form of theta. We don't know theta, so whatever you're going to get at the end of the day is going to be in terms of theta. So if I were you, if you see stuff like this, find the expected value of S. Okay, you need to first write formula for me. Those are the things I actually want to grade. F of S. Here S start from 1 to 4. Based on this, 1 to 4. Okay, it's likely going to change in the real exam. It may not be 1 to 4. Maybe I'm considering 1 to 10. Who knows? Okay, now this as a I'm going to grade this. The fact you write this, even if somebody is not going to write anything again, just this. Of course, there's a grade for that. Okay, now I'm gonna when I equal to 1 over 2 plus 2 theta plus 2, 1 over 2 plus 2 theta plus 3 theta over 2 plus 2 theta plus 4 theta over 2 plus 2 theta. Okay, now since they have the same denominator, I can just write 2 plus 2 theta. I know what I'm just going to be doing 1, 2, 3 theta, 4 theta, or I'm just going to 3 plus 7 theta divided by 2 plus 2. I'm done with that. It's going to be in terms of theta. Okay, that was why you saw that was why you saw this guy. That's whatever you're going to get. It's going to be a function of theta. Okay, is there any questions so far? Because I wanted to go into this exam with high energy. This exam you can just score 100% and, then the final has a huge weight. You know that? Final has a huge weight. Okay, and I think there's going to be some announcements. Check the announcement section. The university wants you to complete SRT. We call it student rating of professor. Okay, if I do bad, put bad. If I do good, put good. Because that is going to be good for the system. So please, it's on the canvas. I think I received the message yesterday. Okay, now you want to find E theta S squared. You do the same. Summation S squared F of S start from 1 to 4. That's going to be number 1, right, in the formula, right? So 1 squared 1 over 2 plus 2 theta, 2 squared 1 over 2 plus 2 theta, 3 squared theta over 2 plus 2 theta, 4 squared theta over 2 plus 2 theta. So if I were you, make sure you come into the exam with a calculator you can trust, because there's going to be a lot of punching that day. So 1, 4, 9 theta plus 16 theta equal 2 plus that. So that's going to be 5 plus 25 theta divided by 2 plus 2 theta. Okay, and here I can factorize 1 plus 5 theta divided by 2 into 1 plus whatever. So I can leave it in. And of course, the variance of S can now be obtained. Okay, you just need to do some algebra. Okay, like putting this guy here now minus the square of this guy. Then you simplify, so you don't. So I'm confirming to you, okay, there's going to be a question that may look like that in the final. Okay? Now, part two, you can see all of them, they've been having part one, part two. That's the way it's going to be. They've been having part one. It's going to be 5 questions in all. Of course, 2 hours exam, because we're all going to be here. Now, part two. Suppose 1 minus 2 to the raised to the power minus 6 is the MGF of a random variable S. Now, if you take a look at this, okay, I told you that is going to be a moment generating function. Do you remember a gamma distribution? That's a moment generating function of a gamma. Okay, you know, the other time I said when S follow gamma with parameter alpha beta, the moment generating function is 1 minus this raised to power that. Okay, if you compare this guy with what I'm giving you now, with this guy now, of course you know that your beta equal to 2 and your alpha equal to 6. Okay, the moment you should be able to recognize whatever moment generating function that you're going to be giving. Okay, so that is for gamma. Okay, now that was why I told you the other time. Why can't you write the moment generating, all the moment generating function I talk about out? Put that into your cheat sheet. You will be allowed to bring it in. You understand what I mean? Okay, now I quickly recognize this guy to be gamma. Okay, the question is asking me. Of course, I'm not going to ask you to use R. I didn't teach R in this class. Okay, now I want to find this probability. Okay, and you know what I'm going to do? Yeah, in the day of exam, I'm actually, you're going to come to this class with your laptop. You know why are you coming to the class with your laptop? Because to be able to use an online calculator. There's an online calculator for gamma. Does that make sense? Make sure you fully charge your laptop. I'm going to send that as an information. Now, I want to find the probability of S less than 5.23. Do you know that if I don't recognize the probability distribution this guy come from, I don't know what to do here because I don't know the probability distribution of the random variable X. But right now, I know it's gamma. Okay, now I need 3 things. I need 3 things to be able to use the online gamma calculator. I'm going to also show you right now. I need a parameter. I need a parameter alpha, beta, and what I want to figure out. 3 things. Now, I'll quickly show you. Okay, now, you know that I need 5.23, I need 6, and I need 2. Okay, I'm going to show you now. Please, I need you to pay attention right now. Oh, my God. This is an online calculator. All what I'm just going to do, plug in 6 for alpha, plug in 2 for that. What you want to find, I'm done. That is the probability. Do you see that? Okay. So that is that. Okay. And let me also tell you another way. I can also use chi-square because gamma and chi-square are related. The only difference is, is that, for chi-squared, when S follow chi-squared with V degree of freedom, okay, the moment generating function is 1 minus 2t raised to the power minus V over 2. But do you know that V is the same thing as the mean, which is alpha beta? Okay, now, and that was why I said here that same question can also be solved using chi-squared. What does it mean here? Alpha times beta. What is alpha times beta? 6 times 2 is 12, right? 12. So if I want to use a chi-square online, I will just check 5.23 against 12, against the mean, against alpha beta. Let me show you a chi-square online. Oh my God, that's a chi-square online. I only need to put a degree of freedom, and yes, I'm done. It's going to give the same result. Like I said, you're going to receive in the announcements, you're going to come into the exam with your whether your laptop or your phone, if you can access what is it called? If you can access the online, but I'm going to be going on to make sure on that day of exam to make sure you are only checking not other things. You get what I mean? So prepare your mind for that. Okay, I'm done with A question. Now the last question for the day. Question B. Fine, we're still focusing on gamma based on the moment generating function here. Now it says find the mean and the variance of S. Then after that, compute this. Of course, there's no way you'll be able to compute this probability without finding without finding mean and variance. Oh, that would be super easy. For gamma distribution, the mean is alpha beta. The variance is alpha beta squared. You remember what we've done before? Expected value of X for the alpha beta. Okay, the variance of X, alpha beta squared. If I were you, why can't you also write in your cheat sheet the mean and variance of all those probability distributions? Does that make sense? Okay, now what does it mean? That would be super cool. What does it mean? 12 alpha times beta. That was why I got this guy. Okay, let me clean up this so that now can you see that the mean is 12. What about the variance? Alpha beta squared, that will be alpha is 6, beta is 2, so 2 squared, the variance is 24. Can you see that? The variance is 24. And let me tell you this. Now I know mu to be 12, then sigma squared to be 24. Of course, the square root of 24 will be sigma. Now the question now, find the absolute value difference of x minus mu less than 2 sigma. Don't forget, in mathematics, if I have absolute value of s less than a, I'll consider negative a and positive a. Does that make sense? Okay, that's exactly what is going on here. Okay, can you see? Do you see that interpretation right now? The probability of the absolute difference between that and that is going to be, if I remove the absolute value, this is going to be negative, negative that, and at the end of the day, it's going to be mu minus this, then mu plus that. What am I going to do? I will need to plug in my mu and sigma. I've already computed them here. And the moment I plug them in, okay, the moment I plug them in, I'm actually going to have this guy. And you know what you're going to do? This guy is the same as whatever you get here. I need to do P. Oh, because of my time. I need to do P of this minus, S less than this. Probability of S less than this minus probability of X less than that. You know what I'm going to do again? I will go back to the online calculator. So what am I plugging in? Okay, I'm plugging in, if I want to use gamma, I'm plugging in 6 for alpha. 6 for alpha, 2 for beta. Then I'll first plug in this value in the X. I'll get that computed. Then I will do the same here. Then I will subtract them. I'm done. Tomorrow, online, I'm going to see, I've already attached that. One of the problems will be on the joint PDF.